Okay, we just want to have a quick look at this lesson I was away for. Uh, but it's a little bit tricky, this one, because we have to process information from secondary sources to actually develop a periodic table by recognizing patterns and trends in the properties of elements, and use available elements to actually predict the characteristics of unknown elements in groups and across periods. So we've got to develop a periodic table. I mean, that's tricky. What we're trying to do is go through the same steps that Mendeleev did when he produced the periodic table, and this all came to recognizing the patterns, periodic patterns that occurred in the periodic table. So let's have a look at this particular question 8 here. So here we are given a list of mystery elements. Okay, these aren't your elements you're familiar with, so they've just been labelled deceivingly with these mystery letters A through to X. We have to figure out how to put them in an order in some type of periodic table. How are we going to do that? Okay, so the first thing that we're going to look at is we're just going to plot some of their features. So for instance, atomic volume against atomic weight. So at this stage, they knew of different elements when they're developing the periodic table. They knew that some elements reacted with hydrogen, oxygen, and the halogens, chlorine, for instance, in certain combinations, and so they could categorize different. They knew that certain things behaved differently. So let's have a look at graphing some of these things. For instance, they could they knew what a mole of a substance was by this stage, and some stuff took up more volume. A mole of one substance took up more volume than a mole of another substance. So, and this relates now to what we call the atomic volume. Okay. Molar volume, sorry. So they called it atomic volume. So let's try plotting this atomic volume against the atomic weights. So they also could weigh things as well. So what we've got is a graph. Okay, we've got some data here, secondary source of information, and we're going to try to plot a graph using atomic volume against atomic weight. So the first thing you want to do is label your graph. Okay, so we're just practicing some skills here in graphing. So here we've got atomic volume on the y-axis and atomic weight, which we know is relative atomic mass on the x-axis. Now, when I noticed some people in class still need some work on deciding the scales of your axes, just remember the key is that it has to be consistent in scale. So you have to really look up the largest number and the smallest number in your list. So for atomic volume, it has to get up to 55.8. Okay, so I mean, when you're looking at this graph here, you got to say, if we go up by ones, obviously that's not going to make it. If we go up by 10, 20, 30, 40, 50, that might, that could work, but it's a smaller graph. You're not making most of it here. I've kind of cheated here. What I'm going to do is just extend this a little bit, because if I go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and then this number is so close to there, we're just going to fit it into this this graph here. as long as my scale's consistent, that's okay. Also, when you have a look at relative atomic mass, what's the largest number there that we're looking for? Atomic weight, so we need to get up to 90 thereabouts. So if we have a look, here we go, sorry, 90, where is it? Largest number. So our scale has to account for that. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90. We get there, going up by fives. Now, I suppose I should point out, you in this case, because we're just practicing here, like you'd want to make sure if it was a test that you would fit it into your scale. But we're doing some. Here, we're really looking at the patterns, so we're not too fussed about this little 0.8. I've just extended the graph to account for that. So I'll set it up and see if we can start plotting the points to see how we go. Okay, so I've been plotting away, and so I mean Q, what I'm looking at, so 35 atomic weight, atomic volume 17, 35, 17. Okay, we look here, and the next one was R, 39 and 46. So I'm just plotting away, and we'll see what pattern comes up after this. Okay, so we're looking at this graph now that we've made, and we're looking for some type of pattern. Now, the pattern that people like Myers and Mendeleev looked at, and they noticed a periodic effect. You know, and it's not really clear, but because there are some things they chose to ignore. But for instance, if you look at, you know, starting here at the peaks and then kind of going up, you know, stopping to the next peak. And now they said, oh, let's just ignore this peak, and you know, starting again, kind of going here and up to here. There's that peak, and again. It's kind of, and this one starting again here. So what did the peaks represent, and did this have some pattern? This is what they're wondering. So so they had this information, but they also had the reactions that they made between like these elements and the compounds they formed, and they could measure the mass. You know, they got an empirical formula. So if you have a look, you can see that in this question that you've got A forms, you know, A dioxide's got two. A oxide, sorry, has got the two A atoms and one oxygen, and you know, they're starting to say, well, what else does that mesh up with? Is there anything else that kind of matches with? And then if you have a look at the next peak, J here, okay, well, then they looked at the compounds that formed. J over here, oh, it also forms a similar compound with oxygen. Oh wait, and also if you look at the compound it forms with chlorine, it also reacts in the same proportion, you know, one A atom to one chlorine, or one J atom to one chlorine atom. And again with the hydrides, the hydrogen compounds, okay, so J and H. So when you started putting this together, you know, it started to form this more coherent type of pattern. And so, you know, it wasn't just Mendeleev who came up with this idea of a table. Lots of people were putting them in different tables and trying to arrange them, and Mendeleev wasn't the first person to do that. So let's have a look now at what we're trying to do here. Now we can see, once we now are taking into account that these different elements A through to X here, mystery elements, what ones are they kind of similar to? So let's go through. Now this is what you should do. Go through this table here and look at that, and any ones that you think are common, like the A and the J are common. What about G? Is G common? It looks similar, doesn't it? So, the other thing to remember, they didn't have all the information here. Not only might they not have found, or reacted G with the chlorine, but that some of these, elements are missing. This is the other key thing. This is what Mendeleev was really. This is the key to the whole thing, was taking into account these elements that hadn't yet been discovered. So have a look at that in a sec. So go ahead now, and so A, J and G match. What else? Well, Q and R, they seem to match. Okay, so go through and have a look, and you should be able to at least identify what you think that some that match, but just ignore that typo there. Okay, but you try and fill in the ones that you think match, and we'll come back and try and make a periodic table of it. Right, so you've put in the letters you think match together, and then, well, we've got that information, but we've also got this idea of that periodic effect, which runs, by the way, in order of atomic weight. So, and this is what they were getting at with they didn't quite know about protons and neutrons yet, but they knew it was increasing in mass, and so let's put them in order just to start with each period starting at a peak. So the first one was A, the next one was J, R, and then W, isn't it, the last one? So in order of atomic weight, and we'll just see how that matches up. So, okay, B, C, D, E, F, G. Okay, so you go fill that in and then start the new row. That's going to be J, K, and so on. Right, okay, so now we've put in our table in order from those peaks. A through to G, J through to P, and R through to V. Now, let's see if these, that follows a pattern going across, fine. What about going down? Does that fit a pattern? Well, A, J and R, they have anything in common? Well, it turns out that, well, A, J and R, they do all form similar compounds. See, well, they're all, so that kind of fits. Yeah, tick, tick, tick. They're all the same type of, they react in the same way. So that fits. Group 2, B, K, and S. Well, they fit. Look like they belong together. Group 3, CLT. They all form compounds in a similar way. Perhaps they belong in the same group. Group 4, DMU. Wait a minute, we've got U here. And that, so D and M seem to go together, but not U. And then, okay, let's come back to that. Well, E and N go together, they seem, but not V. V doesn't seem to be in the right place. So E and N, V doesn't look good. Group 6, F and P. F, P, good. G, well, it's by itself for the time being. But let's come back to U and V. Now, they didn't seem to match really, did they? But if we look at what does U match with, we have U, and if we check U's in the same group as F and P, and F and P is over here. And maybe if we scrub that out and put U over here, that would fit better. And then what about V? What's V like? V is similar to G. Maybe we should put this over here. So this is what this next table was for you to correct it. So you could go ahead and write this new improved periodic table where all the elements have a pattern going across and going down. And now this is where Mendeleev created the genius behind what he did. He said, well, this makes sense really, because, you know, speaking for him here, he says, well, we mustn't have found whatever is here. We'll put U here and V here, and we've created a periodic table with missing spots. And that, you know what? And what he could do is actually, you could look at the empty spot and say, well, I think it's going to behave similar to these other elements in that group. It's going to form compounds in the same empirical formula, which they did. He could even predict the, you know, other physical properties, like melting point, etc. Now, so, and what he called these, he said they were called Eka. Eka. So Eka meaning like. So the space after T here, this one represents an unknown element. Mendeleev would have named what's it like? Now, it's not like T. It's not like the ones in the period. It's like the ones in the group. So they would have called it Eka M. And there you go. So that's basically what this exercise was looking at. What we've done here is we've created our own periodic table, and he just did this to a greater extent. And I mean, what a feat to have! You needed a lot of data to do this, and it needed to be accurate. It needed to you needed to have done all the reactions, so you knew what compounds formed. I mean, there's a lot of work from a lot of people going in to create this. Mendeleev's genius was not only recognizing the patterns and putting it in a table, but really leaving the spaces for the unknown elements. Okay, now you know.